This is the very first lesson for the 7th grade advanced math class in Mr. Reetz's class. I think you're all going to find this lesson to be pretty darn basic, but fear not, we're going to get to some pretty challenging stuff quick enough. The problem you're going to have in this class is an awful lot of what we do is an individual lesson is going to become or is going to be seen as easy to you. It's not going to challenge your brains. But when you take and put this little piece here and that little piece there together and add it all up to one big snowball, that snowball can run you over real simple. So it's real important as you progress through my class that you take time every night to go back, watch these podcasts, and you take time to review the earlier lessons in the chapter every single night so that when the chapter test comes, you're going to be ready to do well on the test and just totally rock it and blow everybody out of the water and get to dance around and say, hoo-ha, look how good I am. Well, don't do that because people will hate you, but that's okay. Anyhow, on to the lesson. Chapter 1, Section 1, using integers to represent quantities. And we should be moving forward, but my thing's not reading. Hold on just a second. Alright, problem's fixed. Let's move forward. A negative number. This is a definition. You're going to find lots of definitions in your lessons, and you are going to have to know all these definitions because we're going to have vocabulary quizzes spread throughout the year. The vocab quizzes are going to be multiple choice, should be pretty easy if you study for them. If you don't study for them, you're going to be like a blind man looking for a black cat in a dark room that isn't there. You just simply won't have a clue where to begin. Negative numbers are numbers that are less than 0. Let's go back in just a second. You can see on that number line there, the numbers to the left of the 0, that's going to be your negative numbers. Your origin is the 0 point on a number line. See the pretty number line? That dot represents the origin, the 0 point. Opposite numbers are numbers that are the same distance from 0 but are on opposite sides of 0. You can say you've got 5 and the opposite of 5 is going to be negative 5. They are opposite numbers, 5 and negative 5. Integers. That's an important term. We're going to be using integers a lot this year. You need to know that an integer represents a whole number, its opposite, and 0. A whole number are numbers such as 1, 2, and 3. Their opposites, negative 1, negative 2, and negative 3, and 0. All those represent integers. So what is an integer not? It cannot be a decimal and it cannot be a fraction. If you see a fraction or a decimal, you automatically know that they are not integers. So is this number an integer? Yes, it is. It is a whole number by definition. How about this number? Is it an integer? No, it is not, because it is a decimal. Remember, integers are whole numbers, they're opposites, and 0. This one has a negative sign right here. That's okay. We can have negative signs, but we cannot have decimal numbers. How about negative 8? Is it an integer? The answer is yes, it is, because it is the opposite of a whole number. Negative 8 is the opposite of whole number 8. So let's use some signs, meaning positive or negative signs, to write each number. For example, a gain of 8 yards in the football game. Somehow the Dolphins managed to get their hands on the ball, and they actually ran it in the same direction, 8 whole yards, before some big 300-pound corn-fed fellow from Robertsdale named Bubba jumped on their face and slammed them down in the mud. But that's okay. They gained 8 yards. We don't care that they died on the football field as long as we win, right? Hoo-ah? No. Football is violent. Be careful out there. A gain of 8 yards would be indicated as a positive 8 on the number line. Yeah, it's a little misaligned there. We'll get over it. How about a hole 19 inches deep? Well, whenever you dig a hole, you're going down. So we're going to indicate the 19 inches deep as a negative 19 inches. How about an airplane at 3,200 feet? That is going to be positive, a plus 3,200 feet. And then a submarine at a depth of 400 feet. That's going to be negative 400 because it's going down. It's under the surface being your 0 point. So 400 feet beneath the surface is going to be a negative 400. What's the opposite of 7 going to be? Negative 7. Wow, this is hard stuff, Mr. Reitz. I don't know how we're going to ever handle advanced math. Fear not, it will get more challenging. The opposite of negative 5? Positive 5. Yep, hard stuff. Not really. Here's some good juicy stuff. Absolute value. The absolute value is defined as a number's distance from 0. Take, for instance, this problem here. Now, you see you've got these two bars here. Let me get my magic pen tool going on here. Push this out. You got this bar right here. Yeah, I missed that one, didn't I? And you've got this bar right here. Two magic bars going up and down, one on either side of your number. What those bars mean is they're saying absolute value. They say the absolute value of 2 is. Well, how far is 2 from 0? That's right here. And you could count it. 1, 2. 2 is going to be 0 places, 2 places from 0. Easy stuff. How about this one? A negative 5, which you can see we've got the absolute value, those symbols here, and we want to know the absolute value of negative 5. Well, how far is 5 from 0? 1, 2, 3, 4, 5. Absolute value of negative 5 is 5. It's a positive answer again. And that leads you to a very important key concept. The answer to an absolute value problem is always positive. Say it out loud. The answer to an absolute value problem is always positive. Now, some of you didn't say it out loud. Say it out loud. The answer to an absolute value problem is always positive. How about this one? What's the absolute value of negative 37? Beep. 37. Wow, hard stuff. What's the absolute value of 67? Beep. 67. The answer to an absolute value problem is always positive. How about this one? The negative absolute value of 32? Beep. Negative 32. But Mr. Reeds, wait a minute, the answer is always positive, and it is. Because take a look here, the 32 is inside the bars. The negative sign is outside the bar. So if we said, well, what's the absolute value of 32? That became our 32. Meanwhile, the negative sign danced over there and stood right in the front. See how easy that works? Let's move on to another lesson. Finish the first one. Let's go to the second one. 1-2, comparing and ordering integers. And by the way, both these are for the first day of class. Using the number line, write an inequality to tell which number is greater. So they want us to use the number line to do that, and they gave us this all pretty number line going on here. And we can take and say, well, you got our negative 5, which is right there, and our negative 10 is right there. The greatest number is the number farthest to the right, which incidentally is also the number that the alligator is going to eat. Therefore, we're going to take and eat the larger number, which is a negative 5. Now, that whole thing that your elementary teachers taught you about how the alligator always eats the larger number, in numbers that works, but in real life, your elementary teachers lied to you. I know alligators. I work with alligators. I wrestle alligators for fun. Don't do that. It's dangerous. They will bite you. Okay? But I do have a good time with alligators. As proof, let's hold on just a second here. There you go. There's some proof. Me holding an alligator by the tail. Yes, she is a very live alligator, very mad because what were we doing right now? At that point in time, well, we were stealing her babies away from her. So I do wrestle alligators in the state park. By the way, if you do things like steal alligators' babies, that's illegal and you can go to jail. We took them away from her because we were putting them in the nature center. You can see right here, there the mama is, and here are some of her babies. Aren't they cute? More babies, mama's in the background. Oh, and there's some deer, but that's not an alligator, so we don't care about that. Back to the math lesson at hand. Let's try another problem. Order this set of numbers from least to greatest. Well, the least number is going to be -20, followed by -2, then 0, and then 16. Problem solved. Now be careful though, because when the test comes, I may, instead of saying least to greatest, I may say greatest to least. So you're going to have to read the wording in the problem to make sure you get it right. Your opportunity to expand your mind tonight is going to be worksheet 1-1, which includes 1-1 and 1-2 in it. Now, don't be confused by this term here, opportunity. I have an opportunity to come to work every day, and if I choose not to come to work, my boss will fire me. Okay? You have an opportunity to do your homework every day. If you choose not to do it, you will get a 0, and then you will have parents upset at you. There will be weeping and gnashing of teeth and screaming and hollering, losing video games, not being able to sleep over at your friend's house. I don't know. The worst parts of the Bible all come together on you. So let's do our homework every night. Take that opportunity to expand your mind and push yourself to be the best you can.
Vlad the Impaler is back. Last year, the mighty Bugatti Veyron starred in our greatest Top Gear challenge ever when it raced an aeroplane across the continent. In that film, Jeremy talked endlessly about the Veyron's ferocious power and its incredible top speed. But because he was on public roads, he had to stick to the speed limit.
But today, we're not going to talk about it. We're going to do it. We're going to take the fastest production car in the world up to its top speed.
That top speed is 253 miles per hour, much faster than a Formula One car. And when you think that the Veyron has airbags, air conditioning, a stereo, a boot, and all the other stuff F1 cars aren't burdened with, you realise what an incredible machine this is.
The Veyron is about pushing the outside of the envelope. It's about doing things that people said just were not possible. This car is a sort of Concorde moment.
Getting the car to do 155 miles per hour, frankly, isn't really very difficult. The Veyron needs just a piffling 270 horsepower to reach that speed. But 253? Crikey!
The faster you go, the more Mother Nature tries to hold you back. So to do the next 100 miles per hour, the 100 miles per hour that takes you up to 250, needs another 730 horsepower.
So what you end up with is a 16-cylinder engine with 4 turbochargers producing 1001 horsepower and a lot of heat.
That's why your car has 1 radiator and this car has 10. The engineers really were in uncharted territory with this car. Here's an example. When they wanted to sort out the high-speed aerodynamics, they went to the Sauber F1 team and they said, "Do you mind awfully if we use your wind tunnel?" And they said, "Terribly sorry, but we don't go up to those speeds."
In fact, cracking 253 miles per hour caused nightmare after nightmare. But Bugatti insists that this £850,000 car can do it. Mind you, actually testing their bold claim is a bit of a palaver. This is Aero Lessine, Volkswagen's maximum security test track in Germany. When it was built during the Cold War, it was deliberately sited in a no-fly zone near the East German border in order to stop prying eyes from seeing secret prototypes. It has over 60 miles of private track, but the bit we're interested in is the main straight, which is a whopping 5.5 miles long. Although it is technically a flat and level road, if you stand here, you can't actually see the other end. And that's because it's following the curvature of the Earth. But even when you've sorted the venue, you can't just jump in the car and go. This is Germany. There are procedures to go through. I like procedures. You have to insert a special key into a slot by the door. And when you do, the diffuser flaps close, the rear spoiler retracts, and the whole car hunkers down to become as slippery as possible. The telemetry box we're using to record the speed measures in kilometers an hour, so the magic number we're looking for is 407.
Right, ladies and gentlemen, here we go. I'm approaching the banking at the top of the circuit. I have to do this at 200 kilometers an hour, that's about 120. Around the banking, look for my acceleration point, then give it the beans down the straight. 200 kilometers an hour, that's 120. Let's get the car settled, fourth gear, 5,000 revs. Looking for the exit, where I bury it. Here we go.
The climb from 200 to 300 kilometers an hour was over in just 9.4 seconds.
The world, viewers, is a total blur. I'm already doing 330 kilometers, going to think I can't do the maths. Getting up to about 350. Captain Slow is doing 360 kilometers, 370.
That's 230 miles per hour. I was now leaving F1 cars behind.
It's no wonder Michael Schumacher retired. He's slower than me. These sort of speeds, this engine is sucking in as much air in a minute as I breathe in 4 days. Getting close to the maximum, which means the tyres will only last for about 50 minutes. But it's okay, because the fuel runs out in 12 minutes. This is a road car and I'm getting up to 404. 405, come on. Come on, give me one more. 406, come on, I need one more. Pretty confident that's as fast as I'm ever going to go in a car. Incredible. That is... it's made my eyes water.
and you